Now let's begin our chapter review. We need to expand this binomial, and we notice the sixth power. The fastest way to do this is using Pascal's triangle and generating those binomial coefficients that we need. So once we get down to this row, 1, 4, 6, 4, 1, 1, 5, 10, 10, 5, 1, 1, 6, 15, 20, 15, 6, 1. Those will be the values of the coefficients that we need. Now let's actually go through and expand this out. We will begin with 1 times 2x to the sixth power times negative 3y to the 0 power plus 6 times 2x to the fifth, decreasing the exponent from 6 to 5, times negative 3y to the first power, plus 15 times 2x to the fourth power times negative 3y to the second power, plus 20 times 2x to the third power times negative 3y to the third power, plus 15 again times 2x to the second power times negative 3y to the fourth power, plus 6 times 2x to the first power times negative 3y to the fifth power, plus 1 times none of the 2x's times negative 3y to the sixth power. Now we just need to do some simplification here. We can ignore the 1, we can ignore anything to the 0 power, so this is going to equal 64x to the sixth minus, because these are alternating back and forth, we have 6 times 32 times negative 3, which turns into negative 576 x to the fifth y plus 15 times 16 times 9, which is 2160 x to the fourth y squared, minus, this becomes 20 times 8 times negative 27, and that's going to give us 43,200 x to the third y to the third, plus, let me move this up a little bit, we're now up to the bottom row there, 15 times 4 times 81, which turns out to be 4,860 x squared y to the fourth, minus 6 times 2 times negative 243, so that becomes minus 4,116 x y to the fifth, and then finally plus 1,029 y to the sixth power. Find the coefficient of the x to the fifth y to the 12th term of this expansion. We know the expansion is going to have a 17 at the top of the binomial coefficient. It's going to have 2x to some power and y to some power. We want the term to have x to the fifth and y to the 12th, and that 12 should match a 12 down here, and these two terms together have exponents adding up to 17, so everything is in check. When you do the expansion of this combination formula, you get 6,188. That will be multiplied by 32x to the fifth, finally times y to the 12th power, and 6,188 times 32 is 198,016 x to the fifth y to the 12th. Find the coefficient. That would only be the 198,016 out in front.